Hello, everyone. Welcome to our study session today. As we're trickling in, if you guys could just put something in the chat, say hello, let me know where you're from, make sure that you guys can hear me and see the screen. That would be great. And we'll just give people a couple minutes to see if we get extra joining. Are you guys able to hear me? Anyone? Hey, yes. Aaron, hi from China. Actually, no, Austin. Hello, hello. From Bulgaria, nice. Okay, so you guys can hear me. Seems. All right. Cool, cool. Australia, yes. Isabel, Australia, nice. Cool. What time is it there for you guys? It's evening, right? I am in Eastern Europe in Estonia, 3 p.m., 6 p.m. Cool. All right. It is 10 a.m. here for me. All right, so let's get started. I'm sure people will trickle in. It looks like I have a hand. How do I let's get okay, so let's get started. If you have any comments, as you can see, I've got the chat up here. If you have any questions or comments, let me know. And we'll get started. So I want to start with some important trig basics. Okay, I think it's really important to have a good foundation to be able to build on. So we're going to go over a couple of the trig basics. We'll talk about the circular functions and their graphs. Okay, it's important to be able to do calculations and also think about it graphically. We'll do some trigonometric equations and we'll do some trigonometric identity work. And just to get started, those of you that are here, if you could let me know, how do you feel about this topic? Do you like trig? Do you feel like it's the worst topic in the whole curriculum? Very confident, not confident, just so I can get an idea of sort of the pace I'd like to try to work at. And in the meantime, I am going to put up the pre-reading. Hopefully you guys had a chance to look at that, but if not, here is a link to the pre-reading. So those are the questions we're going to be working through. And I will also share the slides, but in a little bit. Okay, so let's get going. About partway through, halfway through, maybe I'll share the slides. So, how are we feeling? Feeling good about this? Raring to go? Okay, yeah, trig is something that tends to be taught in the beginning of the course, so it's possible that you have to dig way back in your memory. Okay, yep. So we gotta just hopefully reactivate the memories that are in there. It is easier to revise something than it is to learn it right the first time, so hopefully it will feel pretty good after we get going. All right, so let's go through this. I seem to be missing a slide. That's okay. So just if you guys do have questions, please, please, please put them in the question and answer because that way I know if I've answered it. I can tick them off as I'm going. So I make sure that I answer all your questions. If it gets in the chat, it's possible it gets lost depending on how many people are sending me questions, and I don't want that. So questions in the question and answer, we'll definitely make sure that I get to it. Hopefully I'll get to it right away and sort of in the same question that we're working on. But if it's something, later on and you remembered, uh-oh, I had a question earlier, please still ask and we'll try to sort it. I might leave it till the end, but we'll just see how it goes. Okay. So first and foremost, we need to be able to work in both degrees and radians. Okay, so I have this chart here for the degrees and radians that you should have memorized. Okay, or you need to be able to convert between them. Okay, but the 30, 45, 60, 90, definite ones that you want to know, and then also the other key points on your vertical and horizontal axis. So 180, 270, and 360. Okay. Um, if the question is in degrees, you want to work in degrees. If the question in radians, you should work in radians, but If you switch to degrees because you're more comfortable, do your work and then switch back at the end, that's okay too. But if they give the question in radians, they're sort of expecting a radian answer. But it doesn't mean you have to work in radians. I do find it helps if you're comfortable in both, but either that or you got to be able to switch. And so I like to think about it. I have this sort of circular relationship here coming up on the screen. So if you want to go from degrees to radians, you want to multiply by pi over 180. And if you want to go from radians to degrees, you will go 180 divided by pi. And I always think about it, which do I have and I want to get rid of? Because that's what you need to divide by. Like, so say, for example, if you had, oh, it's not going to let me write. It let me write before. Let's try this. There we go. So if I have 90 degrees, and you should know this, but if you don't, you got to convert it, right? I don't want degrees anymore. So that means that I need to divide by the degree measure to cancel it out. And that's how you can remember, oh, to go from degrees to radians, it's pi divided by 180. So I'm going to cancel out those degree measures as well as reduce my fraction to get to pi over 2. Okay, so even if you don't remember it, some little clues along the way can help trigger those memories. Okay? All right. You are going to want to memorize some trig ratios. I'm sure your teacher has said this at some point. And there's a couple different ways that you can memorize them, but these ones you do need to know. Especially on the paper one questions, if you get stuck with, oh gosh, I need to know what sine theta gives me a half, and you can't remember it, you lose the rest of the question, which can be a little bit painful. If you got stuck on one point, but then you lost 6 more because you couldn't do B or C or D or whatever. Okay, so you want to memorize these. Either memorize the table, like I have here, or we can talk about the unit circle, or we can think about the curves themselves. Okay, so a couple different ways. And we also have the special right triangles. Okay, so either you got this table, maybe take a screenshot, write it down, or maybe you're one. It is possible to get follow-through marks. I was just saying that if you get stuck, it depends on how the parts go. If it's one question with one part and you get stuck, you're not going to get any follow-through, any accuracy marks. You might get method marks still. But if, say, you get stuck on part A and you're able to work forward to B, C, and D, you can get full marks even if you have a wrong answer on part A that carries forward. Okay. But still, I've seen questions where, like, if you can't find the theta measure, you can't go forward. So having a measure is sort of contingent on getting the rest of those points. Like you really just get stuck, you hit a wall. So yes, depending on the situation, you might be able to get some follow-through marks, but you never know. One thing, I don't know, some people maybe have learned this special right triangles. It's a little bit easier to memorize, maybe especially if you're a visual learner. Okay, so we have this 30, 60, 90 degree triangle here. Okay, so we just set up a right triangle, put 30 and 60 in whichever corners you want, and we can figure out with Pythagorean theorem what our sides would be. Right, so if you memorize this picture right in front of you, we can say, oh, okay, so my tangent of 30, I'm down here at this angle, tangent is opposite over adjacent, so the tangent of 30 is 1 over root 3. And that's the same here we have in the table. Okay, so maybe you don't want to memorize the whole table, maybe you like this picture. The other one that you should do is a 45, 45, 90, which remember if they're both 45 on the leg angles here, we will have an isosceles triangle, so both the sides will be 1, and with Pythagorean theorem we could figure out root 2. And now from here, if we say, oh, what is the sine of 45 degrees? Sine is opposite over hypotenuse, so 1 divided by root 2, which is right here. Okay, so either the table, I'm not one to memorize. I don't really do well with the table, but I do like the triangles, I do like the curves. So you got to think about what is the way for you to have these values memorized. Okay. Yes, we got some people asking about different degree measures. You're going to have a calculator. So if, say, it's 37 and 53, Sine of 37, you're going to have a calculator. That'll definitely be a paper 2. These are the angle measures they'll ask about for paper 1. Okay, so these are the ones you need mostly on paper 1. Yes, I'll be sharing the slides in a little bit. I see a lot of you guys using the chat. I will try to keep an eye on the chat, but it is possible that your question gets lost, okay? So just keep that in mind. All right. Okay, so 2 ways to memorize. Maybe you guys have also seen this unit circle and the related angles here. So we just had a table, right, with 0, 30, 45, 60, 90. Here is the radian measure for the exact same angles. And up here, we have both sine and cosine values. So this is the same table that we just looked at. These fractions here have been rationalized. That's fine. They're still the same values. But we'll have cosine is the x values, right? So cosine of 0 is 1. Cosine of 30 is root 3 over 2. Okay, so you just read them sort of the same way you did off of this table, but now we're reading them off of this picture. Okay, so another way that you can memorize if that's how you want to work. And with this, you're going to want to remember this cast diagram, C-A-S-T, cast. Okay. And we have quadrants 1, 2, 3, and 4. And so in quadrant 1, all of the trig ratios are positive. Sine, cosine, and tangent, all of them are positive in quadrant 1. Only the sine is positive in quadrant 2, tangent in quadrant 3, and cosine in quadrant 4. And the way that I like this one because I've had some students in the past that want to memorize literally all the angles for the whole circle. So not the ones they need. So 30, 45, 60 in all 4 quadrants. And that's fine. It's just 4 times more information that you have to try to remember. I like to be really, really confident in this all quadrant 1, and then I just know how to switch it, right? So if I need the sine of, say, 150 over here, I can think about, okay, 150 pairs up with 30, right? That's how I'll do pi minus this 150 or 180 minus 150. So that's the same as 30. And then I think, okay, what is sine of 30? I'll think of my diagram here. I've got sine of 30. Sine is my y coordinate, so this must be a half. So my sine of 30 is a half, and my sine of 150 is also a half because of this cast diagram. So sometimes you might have to use a couple different pieces of information and mesh it all together. Okay. Someone's saying we don't get it. I'll try that again. I did say a lot. Maybe it helps if I write. So let's just take any measure. How about 220? Is 220 a good one? No, 220 is not a good one. Let's do 180 plus. So 210. We'll do 210. Okay, so 210 degrees. Okay. I know over here is 180. Okay, so 210 is going to be a little bit bigger than 180, right? So I must be down in this quadrant 3. And so now I got to think about, okay, if we're doing, say, let's do cosine. Cosine of 210. Okay, so I've got cosine in quadrant 3. I want to figure out what is the related angle in the first one, because that's where I have all of my stuff memorized, is in quadrant 1. And so what I can do is I can think about if I do 210 minus 180, that's 30 degrees, right? 210 minus 180 is 30 degrees. So that means if I think about my 30-degree angles in quadrant 1, I can figure out what I need. Okay, so 30 degrees, I'm looking at cosine of 30 degrees, and cosine is my x values, so that's going to be this one here. Okay, so I'm almost there. I need this root 3 over 2, but I am in the tangent quadrant. Tangent's positive, not cosine. So this is going to be negative root 3 over 2. Okay, it is a couple of steps worth. It's a bit annoying, but you want to figure out the related angle over here. Then you think about either your table or your unit circle or your triangle, and you figure out what the value is. And then you figure out the last thing, what the sign is based on which quadrant it's in. Okay, so it's sort of like 3 steps in one. And I always say it's a little frustrating. The IB expects that you guys pick this up really fast, but it's 3 steps. It's not something that's super fast, right? You need to practice a little bit. So we will be sharing the video. So again, later on, you can look at this again if you want. Maybe it'll help the next time. I think I've got a couple on the next slide that we can try on our own. Just give you guys a minute. Although possibly, maybe it's later. And let me just talk about one more thing. So maybe you guys, maybe the triangle, maybe the circle, maybe you're the curves, okay? That's another good way to think about this. So here's that unit circle that we just had on the last slide, right? We've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we've got that cast diagram going. So all sine, tangent, cosine, okay? And it translates to our curve. Okay, so if I was to take a point here on this curve and I was to rotate it counterclockwise, if I was to rotate around this way in the time curve, I would end up creating my sine curve, right? So I would go up, I'd start at 0, I would go up to 1, I would come back down to 0, I would go down to -1, and then back up to 0. Okay, so my movement around my circle is what creates this nice pretty curve that we have. And as you see here, I've sort of highlighted the colors. So 1 goes with quadrant 1, 2 in quadrant 2, 3 and 4. And this helps you see a little bit. Remember, sine is positive. I kind of want to get a different color here. Let's change colors, see if I can. I can't change quickly. Oh, there we go. Okay, my sine is positive in the all quadrant and the sine quadrant. So 1 and 2. Look, my curve is positive above the x-axis in 1 and 2. Right? So all of this information I can think about in a lot of different ways. And you got to figure out which one's the one that makes sense to you. Right? So maybe it's the cast diagram. Maybe it's literally thinking, okay, I go up for sine and then down for sine. 1 and 2 are positive, 3 and 4 are negative. And you can do the same with the cosine curve as well. I've got that on the next slide. Okay, and you'll see here I've got these measures, right? These again are the measures that came out of the table, that came out of the circle. Okay, and these are the measures as well. So if I've got sine of pi, that's at 0. If I've got sine of 3 pi over 2, that's -1. Okay, so I can read this the same way I read the other stuff. Yeah. And again, here's this curve. Okay, remember this is for sine, so I'm thinking sine is the y values. I'm going up and then coming down. Yep. And now here in cosine, I'm thinking about the x values. All right, so x values. So in that case, I'm starting over here at 1. I'm coming down to 0. I'm coming down a little bit more to -1. And then as I'm coming back up to 0, and I'm going back up to 1. So that's how we get this down to 0, down to -1, up to 0, and then up to +1. Okay, so it all comes together. Maybe it wasn't pointed out clearly to you. Hopefully this will help. But again, it's how you think. I personally like to do a little bit of the circle, a little bit of the curves. My students sometimes make fun of me a little bit because like I'll, as I'm thinking of a question, my hand will go like this. Like I'm visualizing the sine curve, it's going up. Or maybe I'll start going down. I'm visualizing the cosine curve coming down. Okay, so practice a bunch. Still got a little bit of time for the exams, and figure out what one works for you. Yeah. All right. Do I still have? Yeah. Let's try a few. And I'm gonna give you guys just a couple minutes. Just try to think about this. Okay. So either the table or the unit circle or the curve or the triangle, the value of cosine of 240. Okay. Cosine 240, that is in quadrant 3. So what do we do? How do we find that value? Maybe you just know it and you just write it down for me. Maybe you got to do a little bit of work. I'm going to give you just a little bit of a head start and then I'll show you how to do it with, I'm going to have a unit circle pop up here, okay? Okay, someone's saying -1/2. How about other people? Anybody? Anybody either want to support that? They also got negative a half, or maybe someone got a different value? Okay. Seeing another negative a half. Yeah. Ooh, positive a half. Okay. All right. Oh, another negative a half. Okay. It seems like we're leaning towards negative a half. Let's see. Whoops. Oh, yeah. Need room to work, don't I? Okay, so I've got my circle here. Similar to what we did before, but we had cosine 210 before. So I'm in quadrant 3. Okay, so that means I got to do 240 minus 180. That will give me 60. Okay. Now I got to think. So that's, I'm looking at this bar right here, this angle measure here, 60, and I'm looking at cosine. Cosine is x. So that means I want this value here. But I think back, I am in quadrant 3, right? I wrote that down to remind myself. Quadrant 3 is my tangent quadrant, so my cosine cannot be positive. So this is negative a half. Good job, guys. Good job. Who got it? Yep, nice. Okay. Okay, so again, it's a couple steps. Think of the quadrant, think of the value in quadrant 1, think of the answer, cosine, the value, and then think of the sign. Okay. I think I got one more. Yeah, it was a little cast diagram there. It's a little bit late, but that's okay. Here, let me. This one's a little bit different. Okay, now we want the angle measure. So we know that we have negative root 3 over 2. Where does this happen? 30 degrees, 60 degrees, 45? Is it 150? How do we think backwards on this one? Just clean this up a little bit. Got negative pi over 3. Anybody else want to take a guess? Negative pi over 3 being quadrant 4, right? Do we have any other values? Only one answer? Two answers? I probably should have put a range of a domain here. Let's add a domain. Let's say x is within uh, between 0 and 2 pi. Yeah. All right. So I'll talk you through this one. Okay. If you 240 or 300. Okay. I'm seeing some other answers. Sine of 210. Okay. Ooh, got a couple answers. All right, let's work this through. So I'm seeing root 3 over 2 and sine. Okay, so I'm just thinking the sine and root 3 over 2. I'm not worried about the negative right now. Okay. Sine is my y values. Okay. So I'm looking at my y values over here and I'm looking for root 3 over 2. Okay, so that's my y value, root 3 over 2. So that tells me I'm looking at these two angles, if I want degrees or radians, whichever one. Okay, but now I got to think about where is sine negative? Let's come back up here. Where is sine negative? Okay, sine's going to be negative in these two quadrants, or maybe you're thinking, remember, I like to think of this curve. My sine is negative down here in quadrant 3 and 4. So I need to move these into quadrant 3 and quadrant 4. If I want Q3, I'll take 60 degrees plus 180 is 240. And if I want quadrant 4, I can do 2 pi or 360 minus 60 is 300. Okay, so again, it's a lot of tiny little things to do for one question. Okay, take some practice, but you can get it. Okay. So yes, 240 or 300. Those of you guys, negative pi over 3 would have been okay. That's taking from 0 going down to quadrant 4. That would have worked. And what would it be? Either that or 2 pi minus pi over 3. So 5 pi over 3 or 4 pi over 3. Yep. Yep. I'm seeing good answers. Yep. Do be careful with this. Sometimes when they're asking you, they'll ask you, what is sine theta? And sometimes people, they go too far. They find theta. but you only needed to find sine theta. So make sure you're reading carefully. Same thing here. If you're looking for sine x, we're looking for x, right? Solve for x. So your final answer is going to be only the angle measure. Don't give sine of 240 as your final answer. You want 240 as your final answer. You can write them both down, right? Sine 240 equals negative root 3 over 2. Therefore, x equals 240. Okay? Uh-huh. Okay. So don't get how you get two values. Okay, that's one thing that you want to try to remember with the trig. Trig equations, you very, very often have more than one answer. And finding one answer is definitely good. It's definitely worth part of the credit, but you generally want to find the whole thing. So when I added this 0 to 2 pi, that is one full circle. And there's two places for all of our trig ratios, sine, cosine, and tangent, that are going to get repeated in one full circle. So if you're looking from 0 to 2 pi or 0 to 360, or maybe pi to 3 pi, if you have a full rotation, you're always going to be finding two answers. They might try to mix it up and tell you to just give an answer from 0 to pi. Then you got to be careful of which answer is it. But yes, if you're looking at a full circle, right, let's go, I can even go back a little bit here. I'm going to have writing on the page, but if we're looking here, right, cosine of, cosine x is equal to negative a half, right, that's here on this line, and I've got two answers. Okay, if it was cosine is positive root 3 over 2, that would be this line. And again, I've got two answers. So working it through, thinking about what the quadrant is, what the value in the table is, what the sign is, that helps you figure out these two answers. But very, very often, if you've got a full circle, you're going to have two answers. Okay? All right. So let's move on. Characteristics, okay? They seem to like these questions lately where they're asking you to either graph or read the table stuff off the graph. Okay, so let's put this all up on the slide here. We got four things. Okay. All of our trig stuff, sine, cosine, and tangent, all has this periodic behavior. That's what makes them trig functions, right? This periodic behavior is repeating over and over and over. So think about that unit circle. We're going around and around and around, up and down and up and down, around and around. And that's how we get our wave. Okay, so that is periodic behavior, repeats itself. And from that, we have a period for each type of curve. And we want to know what is one full rotation, because it's going to keep repeating. But I just want to focus on what is one. Okay, and one of the best ways to do this is to figure out the distance between either two consecutive maximums or minimums, because sometimes they're going to change the picture they give you, right? So maybe it's between max and max, maybe it's between min and min, maybe it's between minimum and maximum, and you got to double it. Okay, and we'll look at a couple questions in a minute here. But the period is one full rotation, and so you're going to want to look at any graphs and figure out, how long is it on the x-axis to get from one maximum to the next maximum. And you can use these equations that I have here. Let me just sort of draw your attention. If it's sine or cosine, you want to use period is equal to 2 pi over b. This is a formula that's not in your booklet, okay? This is just a relationship that I encourage you to try to remember. But if it's tangent, you got to use period is equal to pi over b, okay? Because sine and cosine take one full circle to repeat, but tangent repeats twice in a circle. So we need a little bit less time to repeat. The last few exams, they've been giving tangent questions because I think they know a lot of students are really ready for sine and cosine, and then they use that one for tangent, but they can't use that one for tangent. Okay, so remember these two things. They're definitely helpful. Sine and cosine is 2 pi over b. Tangent is pi over b. Okay. If we want our amplitude is this green line here. It is the distance from the center line up to the maximum, which will be the same as the distance from the center line to the minimum. Okay, so it's half of the distance of our whole curve vertically. And we can figure out that A value by maximum minus minimum divided by 2. Again, something very useful that's not in your formula booklet. It's a bit of a bummer, I know, but yeah. We want to figure out how tall, amplitude, how tall is my curve, and I want to cut it in half. Okay, if you like formulas, it's this, or maybe you just count. You know, if I'm going from 2 to 8, that's a difference of 6. I take that 6, I cut it in half, I get 3. Okay. And then the other value with our curves, we're going to have this midline. Very often in our functions, which I'll show you on the next slide, we need to find the value of d, which is how this has shifted up or down. And we can calculate that with maximum plus minimum divided by 2. Okay? And that will put us in the middle here. Okay? Similar equations, unfortunately not in your formula booklet. Again, you got to figure out, maybe you're just one. I like to calculate. I like to know I can look at the middle of this curve. The middle is at 5, therefore the answer is 5. That's fine. Maybe you're a calculator. Maybe you really feel confidence in having a formula or something that you can plug numbers into and solve. That's okay too, but then you'll just have to remember these. Okay? All right. Okay, a couple of standard things to remember, if you can, of course. You see, the only way to calculate once you have B and D, right? Very often, yes, C tends to be the last one. It really depends on what information you've got. I'm trying to think if there's a situation. So I've got the formula coming up again. I think things are a little bit out of order here, but hold that thought. Those of you that are C, what is she talking about? C. I have the formula coming up. So, and then I'll get back to this question. Okay. All right. Just a couple of standard things. We know that our domain for both sine and cosine is all real numbers. It's a nice wave. It just keeps on going. And our range, our standard range is -1 to 1. Okay, so if we have any transformations, if we stretched this thing or squished this thing, it might be different. But the standard is from -1 to 1. And that's why if you're trying to calculate, say, sine theta is equal to 3/2, your calculator is going to tell you there's an error because it can't do that. Okay, it's too big. And so this can be helpful. And this is just some ways. I don't know that this is super important. If this is too much info and you're a little stressed out about it, don't panic. Okay, this is something that it might be a little weird how I've written it, and that's okay. Our standard tangent, though, remember, we have asymptotes with this tangent because tangent is sine over cosine, right? Sine theta divided by cosine theta. And so whenever this cosine theta is equal to 0, I can't divide by 0, which means tangent is undefined. And so that's why I get all of these values here, where my domain is not, x cannot be equal to these values, because those are the values when cosine is 0. Okay, just a couple things that can be helpful here. Let me get a glass of water here. There we go. So I like to think about this as transformations, right? So that's why I introduced just here. This is my standard sine curve, my standard cosine curve. No changes have been taken place. It's just sine x. When I come to this slide, I got all sorts of letters that have been squished into this equation, and they all mean something, okay? Anything multiplied in front is a vertical stretch. So if I have my nice pretty sine curve from -1 to 1 and I want it to be taller, I will multiply it by a number and it will get taller. Okay? If I want to squish this left or right, or stretch it maybe, that will be by changing this b value. And that's the one that is associated with the period, right? We just had this 2 pi divided by b, right? That's the period. So b is the element in this formula that will affect my period. I have C here, right? Someone was just asking about the C value, so that horizontal shift. You can figure it out. It depends on what they've given you. You might just be able to like, oh, well, cosine is supposed to start at 1, at 0, at 0, 1. Well, it's over here at pi 1, so the shift must be pi. So you can sort of use some logic to figure out C, but especially if there's a B, value involved and if your graph isn't super accurate. Maybe they haven't given you the right known point to logic that out. But our C is our horizontal shift. Okay, like I said, cosine should start at 0, 1, but if it starts, that maximum is a little bit off the axis, that is because of this C value. And then if this is up or down, it should be centered on 0. But if I have a plus or minus D, that center line will either move up or move down. Okay? And that was the formulas that I had before, right? The D was equal to the max plus min divided by 2. And A was max minus min divided by 2, right? So those values on that previous slide will help you find B's. And that's why this question that I just had was, what about C? Well, if you find A, B, and D, you can calculate for C, which is very typically the order that you'll solve for things. But the good part is the question does try to guide you, right? If they've asked you to find B and D, and then they ask you to find C, they're sort of telling you that it's a whole lot easier to find B and D first and then find C after. Okay? You might be able to find a way around it. It's possible, depending on the information, but they do guide you into this is a good way to do this. All right, how we doing? Doing all right? I think we're getting close to questions. What does the transformations mean? That is where to use. I'm not sure I understand. Like a transformation would be how your curve is different from the standard curve. And so this is just one way to think about it. You don't have to. I know a lot of students, maybe they don't, the visual, like what these numbers do, A, B, C, and D, what they do to the picture, it isn't always well explained. So it might not be something that makes perfect sense right now. But hopefully the question that we look at, maybe that will help. Vertical stretches, X, the Y values, horizontal. Yep. I like to think about it. For me, the values closest to X, right? So that would be this B and C value. These are the closest to my X. That's my horizontal stuff. My horizontal effects with X. And the vertical, that's the stuff on the outside, my A and D. It's a little bit further away from X. That's my vertical, my Y stuff. Questions we got to our Gmail. Yes, we are going to be going, I think we're getting into it just in the next minute or so. I just want to make sure, point out, order matters. So you really got to do your order of operations. Okay, and that's why I've bracketed this X plus C here, because it could be given that this is distributed in, and then that can get a little bit tricky. Okay, but I've got a question coming up that I think in the session that we sent out, the email that we sent out, let's get to that question. Oh, there it is. Okay, perfect. All right, yeah, so we're going to get into these questions, and I will share the slides. Actually, a couple of you guys maybe want to look ahead if you've done a little work. I will share the slides right now. That should be the slides. Let me know if I didn't. I believe it's been set up that you can't download. I apologize, but that's just how we run these. But you can look at it. You can save it. This link will not disappear on you. You can save this link and come back to it, so you don't really have to download it. Just save this link somewhere. Okay. All right. So let f of x equal a sine b times x plus c plus d. Part of the graph is shown below. This is a very sort of standard type of IB question. And for part A, we need to find the value of A, D, and B. Okay. So I always like to draw this horizontal line in here because this will help to figure out some of these values. Okay, so I'm looking halfway between this A and B. I'm going to draw myself a line just to have that visual. My A, I know, is going to be between that midline and the maximum. Okay, and so this is the A value that we're looking for. It's the same if I'm down here, right? Maybe you don't have the full curve, so you're only looking at the lower part or the upper part. We know it's between the midline and the max or min. Okay, so this whole thing is 2A, right? If I've got A above the line and A below the line, the whole thing is 2A. And so I can figure out, looking at my Y values, how big is this thing? If I do 5 minus -1, right? So that's There's my 5 and my -1. I'm looking at the y values. Put those together, I'll get 6. 6 divided by 2 is 3. Okay? So that's the value for A. And again, looking at the y values, figure out the distance. The other thing you could do is just count. Well, that's negative. There's 1 there, plus 5 there. That's 6. 6 divided by 2, because I only get half of it, is A. All right, so part D here, so A2 for the variable D, that's the distance between X and this midline. My standard curve starts at 0, but this is not at 0. This got moved. So something moved it. That was this line, this D value at the end is what moved this thing. So if I can figure out how high this is, then I know how it moved. I can use that equation I mentioned earlier. We're going to take again the y values. I'm going to now add them instead of subtracting them. So 5 plus -1, that's 4. 4 divided by 2 is 2. So now I know that this value, everything about this whole curve moved up. We're using the y values because A and D are further away, so these are the vertical transformations. Okay, we're going to use the x values too a little bit, depending. This is a non-calculator. Okay, yeah. So for A and D, we're using the y values. Okay, those are the vertical stretches. The B and C are close to x. Those are the horizontal, the x axis stuff. Okay. So for B, remember B is the period, the length of time it takes to do one full rotation. I didn't have the full, I extended my picture here just to sort of help me think about this. And so now I have the full period just visualized for here. And we can use that formula. Remember, we had this 2 pi divided by b for sine. And I've only got half the period. That's okay. I can figure out the distance between these two things and then double it to get the whole period. Okay? So my period is going to be 2 times the difference from 1 to 3. I see a couple questions. I'll get to them in just a sec. So from A to B, moving this way, I've gone 2 units, right? From the 1 to the 3, I've added 2 units, and then I'm going to double that to get my full period. So the period from this maximum to this maximum must be 4 units. I'm not looking for the period, I'm looking for B. So I now have to go to that formula I mentioned a couple slides back, and I can put this 4 on the left-hand side, and then I can solve for B. When I do that, I'll cross multiply. I'll get 2 pi divided by 4, and so B is pi divided by 2. All right, let me look. For D, I would minus A from 5. Yeah, yes, you could absolutely do that. Yep, if you've already done A, that's someone's pointing out here that we need to know where this blue line is here, this horizontal. We found that A was 3, 5 minus 3 is 2. Perfectly fine, yep. How do we use this? AD minus Y plus BC minus X. I am not sure about that one. How to know and use AD equals Y and BC equals X. I have not seen that. I'm going to write that down for myself and maybe look into that a little bit. There's other ways to go about this, absolutely. Again, I think it depends on how you learn and how you remember things, if you're someone who likes to memorize. I'm a very visual, so as you see here, I'm marking up my picture and making little notes to myself, and that's how I like to work. But there are other approaches that might work differently for you, for your teacher. What we connected? So you mean, okay, so when we're searching for A and D, we're going to use Y values. And when we're searching for B or C, we're probably going to use X values. So you don't, I think my question's clarified here. So the A, B, C, and D, the B and C are I almost hate to use A, B, and C. They might change the letters on you. They might call it P, R, and Q, right? They do that sometimes. It sucks. The letters closest to X inside sine. Okay, so these extra letters inside the sine function, that's when we're going to be considering x values because those are horizontal shifts. Anything that's outside the sign, outside the function, we can think of this as a composite function, right? Stuff is inside, that's a composite function, and the stuff on the outside. The outside stuff, we're going to be looking at the y values. Okay? Yeah. I don't know. I think, yes, good. Okay. Good. Okay. And a little bit more. It says, hence calculate the value of c. Okay, I think I've got that all on the next slide. So let's remember, we got a is 3, d is 2, and b is pi over 2. Okay, so I can go back if you all need, but yeah, a is 3, d is 2, and b is pi over 2. And so now if we need to calculate, right, we can look at the question for clues. Calculate means I'm going to have to do some math here. And let's substitute these values into our equation. Okay, so now my equation looks like this. And I've got three kind of unknowns, right? I've got f of x, which is y. I've got x, and I've got c. If I want to solve this or if I want to calculate stuff, I need to only have one. Let's get rid of x and y because I know two places on this curve where I know x and y. And if I substitute those in, then I can solve, I can calculate for c. Okay, I believe I took, yep, this one because I like working with one. It's a little bit easier than working with the 3 or the 5, but by all means, if you like the 3 and the 5, that's okay. Um, so I calculated with the 1 and the minus 1. And let's see. So subtracting 2 first, right? So 2 comes to the other side. I've got minus 3. Then I'm going to divide. I'll have negative 1 is equal to sign. I'm trying to get all of the numbers away from C. Okay? So I moved the 2 first. I'm getting rid of the 3 next. Now I need to think about where is this sign equal to negative 1. That's what we talked about with our unit circle. And so thinking about this, sign is negative 1 at negative pi over 2, right? Or 3 pi over 2. Yeah. And then I'm going to divide by pi over 2. So I get negative 1. And then I can move the negative 1. And I'll get c is negative 2. Okay. You may have got a different answer. And that's okay. Don't panic. It depends on, remember, this is a horizontal shift. So if you take one point as your start point, maybe that shifted it to the right. You'd still get the exact same curve if you got a different C that maybe shifted it to the left. Okay, so it is possible that your C value is a little bit different. I think if it was IB, they would give you a range, or they would make it, they would phrase it in a way that you're going to get the right answer. Okay, so it is possible that you got a different value. It's okay. Essentially what I did, remember cosine should have started here. Mine got shifted that way. Okay, but right, cosine starts here, right? You could have shifted it this way to that maximum, or we could have shifted it that way to that maximum. Okay. All right. How are we doing? You guys still with me? uh, 1 second, guys. Give me a second here. Yes. Sorry about that. All right. And so, yep, -2. All right, let's look at another one. So they could ask you to have a graph and pull information out of it. They could ask you to graph stuff. Okay. So here we have one where we have a nice pretty function and we have to put it onto our grid. And they're going to start by giving you some information. They're going to sort of help you in the right direction. Okay, so write down the amplitude, write down the period. That's helping you get information to draw your graph. Yes, if there was multiple answers, you could put either one, and the examiners would have notes that you, this is to the last question, sorry. If there were multiple correct answers, the examiners would have a note which answers to be looking for. So you don't have to worry. Do your calculations and circle what you believe is your answer so that they know for sure, and that's what you need. Yeah. Okay. Um, so write down the amplitude. Write down as a command term, and it hints to you that you don't have to do a ton of work. Okay, if you're doing a lot of calculations, you might be trying something too hard. Okay, write down the amplitude. That means, remember, amplitude is our A value. That's that -2 in front here. And so amplitude is 2. I've included this one because it's a little bit tricky. The negative sign is not part of the amplitude. The amplitude is just how much this thing stretches. Okay. I suspect you would not get credit if you had -2. It really depends on the mark scheme and what the IB examiners decide. But this is something you're going to want to kind of remember. That's why I included it. Amplitude is the absolute value of A. Okay. And now the period is, remember this 2 pi over B. So B is this 1/2, the value that's multiplied with X. So I've got my formula here, 2 pi over B. I'm using this one because it's sine. If it's tangent, we got to use the other one. And so I'll have 2 pi over 1/2. And the division becomes the multiplication. And maybe you guys have heard of this dot flip, right? So 2 pi, I change division into multiplication, and then I flip the denominator, and that gives me 4 pi. Okay, so division of a fraction, you can turn it into multiplication times the reciprocal. Flip that bottom fraction. Okay, so there's the period they asked me to write down. And now we need to hence sketch f of x. Okay. Hence includes that we're going to use this information. That's so we've gotten something that can help us. And I always like to start with drawing the regular one. You don't have to do this, but this just helps me visualize. This would be my standard sine curve. It goes from 0 up to 1, back to 0, down to -1, and back to 0 at 2 pi. Okay, so this is my standard curve, and now I'm going to apply all these transformations from these numbers to get to my final picture. Someone's asking me if the 2 pi over b formula is not in the booklet, how do they want you to obtain the period? I think they just expect you to, you're not required to use the formula. I think they're expecting you to just look at, oh, well, sine goes from 0 to 0 over 2 pi, and they expect you to look at the curve if they've given you the picture. In this one, this is a non-calculator. They would not have given you the picture. I think they just expect you to know this formula. Yeah. I disagree. I think they should be in the formula booklet, but I did not have a say in that, unfortunately. So, there's a few things. This was not too bad. There's a few things that you should just memorize. A lot of things you don't have to stress out because they are in the booklet. So, yeah, just as you're making your study notes, just write this down, kind of star it that this is one you want to try to memorize. Okay, so here's my standard sine curve. I want to apply this -2. So what that means is I need this to get 2 times taller. So from 1, let me get my pen here. From 1, I need to make that jump up to 2. And that negative will flip this thing over the x-axis. So instead of being at +2, now I'm down at -2. And similarly over here, I had it at 1. I need to double it. I need to make it 2, so it would come down to here. And then with the negative, it flips up. So that's how I've gotten this blue curve. This blue curve is only applying that -2. Okay, I haven't touched the half, I haven't touched pi over 4, I haven't touched 3 yet. I've only flipped my curve upside down with -2. Next thing I want to consider is my -3. I like doing the vertical stuff first because the horizontal is a little tricky sometimes, but the vertical stuff is very straightforward. You can do it first, you can do it last. I like to do it first. So I'm going to look at this -3. -3 means I'm taking this whole curve and I'm dropping it down 3 units, every single thing. Okay, so my 0 drops down to -3. My -1 drops down to -4. This 0 to 0, right? This whole thing has got dropped 3 units. Okay, So now I've applied this red curve down there. I've applied the -2, and I've applied the -3. I still have to deal with the half and the pi over 4, negative pi over 4. Yeah. I have up here factorized the half because I want to be able to apply the transformations directly as I see them. The half tells me that one period is going to be twice as long. It's the opposite of what we expect. Okay? And you can also use this information that we just found. We found that period was 4 pi. That means that this curve, I can only see one rotation in all of 4 pi. So what I have to do is take this thing, I need to stretch it out, right? If I was supposed to see more than one, if my curve was smaller, I'd squish it. But my period, which was 2 pi, is now 4 pi. So I'm going to stretch this thing out. Yeah? Although, what am I doing? Yep, dealing with the half first. Yep, so we have the half. Half is 4 pi. And so everything is going to be stretched. And you'll see here I've stretched this. So 0 stays at 0. My, what is at 1 jumps to 2. What was here, actually, that's not, sorry, that's pi, pi over 2 jumps to pi. 3 pi over 2 jumps, everything is jumping, it's doubling where it was. It's doubling in the x direction. So this was a pi, now it's a 2 pi. This was at 3 pi over 2, so now it is at 3 pi. Right, 3 pi over 2 times 2 is 3 pi. So everything doubled in my x direction. 2 pi jumped to 4. So the further you get away from your y-axis, the further it jumps when it doubles, right? Doing okay? Doing okay. All right. So now I've dealt with a lot of this. I still have to deal with this minus pi over 2. Oops. Get rid of that one so it's not distracting. Okay. And now this green curve, so minus pi over 2, this is my horizontal shift. I need to move this one way or the other. Okay, moving it in the x direction. And we want to do negative pi over 2. The horizontal stuff is opposite to what we expect. I would think negative pi over 2 moves it in the negative direction. Unfortunately, it does not. It moves it in the opposite direction. Okay, so I'm going to need to move my entire curve, pi over 2 units, to the right. Yeah, to the right. Okay, so you see here I've got those arrows, and I'm indicating every single point. And technically, I would move this point as well, but it starts falling off my curve, so I don't need that anymore. And I'm going to shift this over, and then this green curve is what we want. Oh, I'm sorry, I'm getting too far ahead of myself. Okay. I did pick a hard question. Very, very often, especially on the SL ones, they usually only give you B or C. It's not as common to have both B and C. But I picked this one because I wanted to give you guys a little challenge and also take the opportunity to talk about how you would work through it. Okay, so try to practice a couple of these. And we have no idea what'll be on the exams, but hopefully it's only a B or C. I know when I'm looking at new questions, I'm hoping it's only B or C, not both. They can give you both, but it's less common. Okay, not impossible, less common. All right. Yes, we'll get the recording up. It's all on the dev team. As soon as I finish, I will send it to them and they'll get it up on the website as soon as possible. I shared the slides. I'll share them quickly again just in case. And actually, if you want, I have a feedback form here. I would appreciate a couple of points of feedback. Anything that can help me do better next time would be great if you have time. I will share that again later as well. Okay. And then finally, determine the value of x when y is equal to -3. Now, once we have this nice pretty picture, even if you've drawn this wrong, draw this line. Y is equal to -3. And whatever your curve intersects this is where we get those follow-through marks. Even if this curve is wrong, You've drawn your curve. If you write down the answers where they intersect, you get follow-through marks. If you write them down correctly, of course. Okay, so I've drawn my line. I'm looking, these are the 2 points where they intersect, and that would be pi over 2, right? It's a little bit hard to see because of the axis. This would be pi, and so this will be pi over 2. And then, again, this is pi, so this is 3 pi, and so halfway between 2 pi and 3 pi is 5 pi over 2. So because that's where these two things intersect, those are my two answers. And again, if you don't worry about whether you graphed it right or wrong, do your best graphing it, and then for part C, answer the question based on your info, okay? You'll get the follow-through marks. All right, a couple more stuff. Oh goodness, what's this? Ah, yes, we probably should talk about the calculator here. We can certainly graph this. And so I just wanted to take this opportunity. You don't have to do what I did back here. I factorized this because I like to think, okay, this is half, so I'm doubling everything. This is minus a half, so I just have to shift it a little bit. But you can keep it in this form, and then you have to do the shift first and then the stretch. I like to do the stretch first and then the shift. Okay? And so I think I have this curve. I do. Let's see if this is going to come up. This is super cool. Of course, it's hiding on me now. Yeah. Come here. Yep, sorry, I was trying to pull it back over here. Yep, sorry. You guys, now we can see it? Lost all my boxes. All right, now let me get the comment boxes back because if you guys have questions, I want to be able to see them. Yes, using your calculator. I mean, you just got to, whatever the question is, if you're working in degrees, you got to make sure it's in degrees. I would say start it in radians and only switch it to degrees if you're very confidently working in degrees. Because there are some other things where you're using pi, where like maybe some derivative stuff where you really want it to be in radian measure. I would say for the most part, leave it in radian measure and switch it to degrees for degree questions. And then probably I would say switch it back too. Okay. Throughout these, yeah. Well, I mean, your other subjects, I don't know. I don't think it matters if you're in radian or degrees for your other subjects. I would ask your other teachers. Um, I, each school is different. Our school always resets the calculator, and that kind of auto sets it to radian. So figure out how your coordinator will handle that. Huh? Um, so just here, so I've got this up, and you guys should be able to access this GeoGebra as well if you want. So here I've shown the 2x. So you just turn things on as you're working through. So we started with the regular sine curve. We went to -2. Then we went down to -3. Then we shifted it. Actually, this is the different one. So then we did this one. Which one did we do? We did this one. We stretched it, right? And then we shifted it. So that was the path that we just took, is this pink one. But the other way, right? So I say I'll come back to the slides so it helps you to see. We could do this one and then shift it first and then stretch it. Okay, and notice these curves are sitting right on top of each other. You almost can't see that gray one. It looks like it just made it a dark pink, huh? Okay, so there's two different ways to handle the horizontal shifts. And either you factorize, that's the way I like to do it. So I've over the years I've figured out like I like to stretch then shift. And so I have to make sure my form of my equation is in this form. Whoa, go back. Okay. It's just a factorization, not a problem. If you don't want to deal with that, if you're comfortable going it this way, leave it bx plus c, and then you shift it first, and then you stretch it. Okay? And again, you'll have this, I've shared the slides, I'll share them again at the end. You should have access to this, and you can play around with the order. Okay? All right. Question 3. All right. I'm going to go through this one a little bit faster. I just want to point, like you can be given a question where you don't have a picture and you're not expected to draw a picture. But you still need to figure out some of these A, B, and C values. Okay. So given that the period is 2 pi, sorry, 12 pi, find the values of A, B, and C. Well, they're telling you period, so we know we can use this formula, and so we can solve for B. Okay. What have I done here? Ah, yes. Looking at my equation up here. B it's a little confusing. B is actually 1 over B, right? I'm looking at the thing multiplied by x. So when I substitute that thing multiplied by x, I get 1 over B, which remember we talked about as a dot flip. So I've flipped 1 over B so that it's B over 1. And so now I have this equation, and then when I divide, I get B is 6. Okay, so I started looking at my variable. Again, they can change the letters and be a little confusing sometimes, but I think about the relationship. The thing multiplied with B, that's what I use in this equation, right? If it's R, if it's P, if it's M, we can still use this equation. Whatever is multiplied with X goes here. Okay. What do we need? A, B, and C. So we've got B, and now we want A and C. Well, I have this equation here. Okay. So I have a point. I can always substitute a point into this equation. Remember, put the X in the right spot and the Y in the right spot. And I can do the same thing with the other point. Okay. I don't have max. I don't have min. I don't have that midpoint. Or I could try to calculate it, I suppose. But we don't know that these are maximums and minimums. We only know that those 2 points in red and green are on the line. So I don't want to start trying to use maximum and minimums, those formulas I gave you earlier, without knowing for sure that it's a maximum and a minimum. I don't know. So we got to go a different route. And that's why I included this question. So we substitute this stuff in. Then we can simplify a little bit, right? So here's where I was saying earlier, you have to have those memorized. Here you might get stuck. Maybe you're really good at systems of equations. That's where we're headed. But if you can't simplify the cosine pi over 6, you're stuck, right? So having these memorized is really important. Okay, so this is the second one, cosine pi over 6. If we're thinking back, that's root 3 over 2. And that's quadrant 1, it's positive. So, and then I can do a little bit of rearranging here. Actually, no, this is the second one. So 2 pi over 6 is pi over 3. Cosine of pi over 3 is a half. And so this is my second equation. I probably should have made that a little bit more clear. And now I want to eliminate a value and solve for C. I see these are lined up and I see if I have the same value of C. I have 1C in the first equation, 1C in the second. If I subtract everything, then I can solve for C because my C will disappear, right? C minus C is 0. So I'll have root 3 minus 1 minus 0 on the left, root 3 over 2a minus 1/2 a on the right. I'm going to factorize this to make it a little bit nicer. And you'll maybe start to see that I've got something similar on the left and on the right. If I cross multiply, my 2 will come up, my root 3 minus 1 will go down, and I can cancel that, and I can get as a is 2. Okay. Working with stuff like this is a little bit uncomfortable. Those square roots are uncomfortable. Ideally, you get the half, right? Cosine a half, or cosine takes you to a half. But if it's paper 1, it's workable. Okay, so if you start getting some crazy answers, maybe pause and back up a little bit because a paper 1, even if it's uncomfortable, a little challenging, it should still work out to a reasonable answer. Okay, if it's paper 2, all bets are off, you have your calculator. But paper 1, I mean, I would expect, even though it's messy, a equals 2 is a really nice answer. I'm feeling kind of confident about it, if that makes sense. And then we need to find C. Well, so if we have this equation here, I got a is 2. I'm going to substitute it back into this equation here. 0 is equal to 1/2 a plus, plus c. So 1/2 times 2 is 1. I'll subtract 1 to the left, and I get c is minus 1. Okay. So just another type of solving question that we can use our transformation knowledge, but we do need to be a little bit careful. Oh goodness, one more. Oh, still haven't. This, see, this is, I'm accidentally modeling what you need to do in the exams. Make sure you go back and read the question because I popped to the next slide. I'm like, oh, we're doing it again. No, I forgot about B. Okay, so a lot of times you're working through a question, you're feeling really, oh, yes, I got an answer. It makes sense. I'm feeling good. And then you jump to the next page and you totally forgot about part B, or maybe you didn't actually fully answer the whole question. Like maybe you were supposed to, put it in a radian measure and you left it in degrees. Go back and read the question because there's a couple of points at the end that might be really super easy points um, that if you don't read it, if you get so excited and you move to the next question, you lose out on a couple easy points. Okay, so all right, so part B, we got to write down the possible values of P. So y equals P is tangent to F. Okay, first thing we want to talk about is that, well, okay, here's my values from before, and here's my equation. Okay, I'm substituting those into my equation. Now I have this line. I'm just going to draw a sort of something to visualize this random cosine curve. Okay, it's not accurate. This is moved and stretched, but if I have a horizontal line, y equals p is horizontal. Y equals 3, y equals -2, right? It's a horizontal line. What are the possible ways that this could be tangent to pi? Sorry, to f, tangent to f. The only way that it can be tangent is if it's touching at one point, and so it's going to be at the maximum or the minimum, right? Otherwise, if I had a tangent, I would have something coming off at an angle, and we can tell from our equation that we don't have that. So the only way that I can have this is if it's touching the maximum or the minimum, and then I can try to figure out how does that work, okay? My standard curve is between -1 and 1, I know that. Well, my curve is a little bit different. I can take these values and figure out what happened on my curve, right? If I take the maximum cosine value and I substitute this in place here, I'll have 2 times 1 minus 1, which is 1. So the maximum on my curve is 1. I'll take this minus curve and replace it for this cosine, and then I'll solve, oh, what is this? Oh yeah, the simplifying. I'll take this minus 1, substitute it here. 2 times minus 1 is -2, minus 1 is -3. So that tells me on my curve, my maximum is at 1 and my minimum is at -3. You could have done the transformation stuff we just talked about where you think about, okay, I've stretched, so from -1 to 1, I've stretched it. So that's -2 to 2. And then I've dropped it down 1. So that's -3 to 1. Okay, so another way to think about it, you can substitute some values. You can think about how it shifts. Yeah. All right. Couple of things to keep in mind. I am going a little bit slower than I would like, but let's just keep in mind. I definitely will stop it at 2 hours if it takes too long. Okay, so hang with me as long as you can. Let me know if you need the slides again, and we'll try to pick up the pace just a bit. A few things to keep in mind for trig equations. Check your domain. Remember, I said earlier there's multiple answers, so check the domain and consider the number of solutions. Maybe there's 1, maybe there's 2, maybe there's 4. Okay. And if it's paper 1, we want to try to manipulate to one trig equation. If we've got sine and cosine together or sine and tangent together, that's hard to solve on a paper 1. So try to manipulate one into another. If it's paper 2, go straight to your equation solver or your graph. All right, don't mess around with trying to manipulate. You might make a mistake. Paper 2, train yourself. Go straight to that calculator and let it do some of the heavy lifting for you. Okay? And the trig identities. Sometimes if you get stuck, the trig identities are the way to go. Okay, so we'll look at a couple of those. Don't forget them. Those are in your booklet. Okay, so you don't have to memorize them, but try to remember. Okay, so here's an important trig identities. These ones are in your formula booklet. I just want to point out that IB likes to have you manipulate these. Okay, so they'll give you these and then they'll expect you to use these. Okay, so keep in mind what's in the equation as well, right? Maybe if you need sine squared, you could use this one, or you could use this one. Or you could actually use this one too, depending. Okay, so sometimes you have the thing you need right on the left-hand side, which is great. Sometimes the thing you need is on the right-hand side and you can move stuff to make it work. Okay, so question 4 on that sheet, solve 2 sine x is equal to root 2 tan x. Okay, again, we want to, this is a non-calculator, so we want to try to manipulate something to be a single trig ratio here. I don't want both sine and tangent. So I'm going to change tangent to sine over cosine. Okay, still 2, but let's see if I can sort of manipulate this a bit. I like that I have sine on both sides now. Okay. If I multiply my cosine up to the left-hand side, I've gotten rid of that fraction. I don't really like to work with fractions if I don't have to. And I'm tempted to divide by sine x, but there are places where sine x is 0, and I'm not allowed to divide by 0. You'd never, never, never want to divide a variable. Okay? If I've got x, I don't want to divide by sine x. Okay? So I can't divide. I'm going to move everything to the left-hand side. Okay? I'll subtract that root 2 sine x to the left, and now I'll factorize sine x. And now I still have the two trig functions, but they're separate, right? And I have these two things multiplied to 0, which means one of them must be 0. Okay, either sine x is 0 or 2 cosine x minus root 2 is 0. One of these is 0 because I ended up with 0. This is where we're going to think back to our trig ratios, stuff we have memorized. Remember, sine starts at 0, pi, and 2 pi. So those are my x values there. And I can shift those, right? Unfortunately, oops, wrong pen. I'm looking at this. So the 0 is fine, the pi is fine, but unfortunately this 2 pi, I gotta go backwards. I gotta go the other way. So if I'm thinking about my sine curve, I've got my sine curve like this. I can just extend this back over here. So these are my 3 answers instead of these. Right, from my unit circle, I would have got the blue ones, but I just shifted it a little bit to get the red ones, which is what I need. Yeah. Solving this one on the right, I'm going to add root 2. I'll divide by 2, so that gives me cosine x is root 2 over 2. Thinking back, that's 45 degrees. Okay, so now I want 45 degrees or pi over 4, and then I need to think about where is cosine x positive. It's positive in 1 and quadrant 4. So I need pi over 4 in quadrant 4, and I get that from 2 pi. Well, I could just drop it minus pi over 4, or I could do 2 pi minus. But we got to think about our domain. Right, so negative pi over 4. If I went forward, if I tried to do 360 minus 45, I would be outside of my domain. So to stay in the domain, I gotta go from 0 backwards. And again, it's possible you'd get answers with degree measure, right? If you're uncomfortable in radians, it's possible they expect you to answer in radians, but you might still get credit in degrees. Definitely better to solve it in degrees than to not solve it at all. But yeah, try to familiarize yourself with radians if you're not there yet. So yeah, so thinking about so they're asking how did we get these 0 pi and 2 pi? I'm just going to grab a different color here again. Let's go purple. Where is sine equal to 0? The 0 line is here. So I'm thinking about where is this red curve equal to 0? It's here and here and here. And just the pattern that we need to know, that's 0, pi, and 2 pi. And so those, and again, write those down. You get credit for some of them. And if you remember to think about, okay, well, they're telling me I want to work between negative pi and pi. So this is the domain where I need my answers. So you could connect the curve backwards a little bit and still have the sine curve, but in the right interval. Yeah. Okay. Yes. So like I said, you could have multiple answers. This one has 5. I don't suspect they'll ask for 5 on the IB exam, but they might. So practice. Okay. All right. Question 5. This one's tough. Which is why I picked it. I wanna help you guys to be confident and ready. So with this cosine 4x, yeah, what do I show that? Okay, show that. How do I do that? First thing you want to do is look at your identities, right? We have cosine 4x, which is, I can write this as a double identity, right? I've got this cosine 2 theta, and I've got a lot of different options. So if I write 4 as 2 times 2, now I can pick one of these. I'm headed, looking at where I'm going, I'm headed for stuff with cosine. So I'm going to choose this one because it keeps it all in cosine. I don't want sine, I'm looking for cosine. So my x value is 2x, so over here, right, this theta will go here. My theta will go there as well. Yeah, so 2 cosine squared, 2x minus 1. I can rewrite the square because I'm going to expand this, right? You can either write it in here or write it out here. Those are both the exact same thing. And I did that because I'm going to use my identity again. All right, here's my identity used again for this one. Okay, if I'm doing a double angle down to, so 4 down to 2, 2 down to 1, I'm doing 2 times my double angle formula. And again, I'm still focused on ending with only cosine, so that's why I've used, excuse me, the same one twice. Now I'm going to expand this set of brackets here. 2 times, so I'll have 2 cosine squared x times 2 cosine squared x, that's 4 cosine 4x. Then I'll have 2 cosine squared x times minus 1 plus negative 1 times 2 cosine squared x. I'll have negative 4 cosine squared x. Negative 1 times negative 1 is positive 1. And then I'm going to expand this 2, right? I'll share the 2 with all of these, oh, that one over there. And then I will get what I need according to this given. I got to combine my 2 and my 1, and then this is as required. Good things about show that questions. Use what they've given you. Okay, if you get stuck, if you didn't recognize the identity, if you didn't get all the way through this, probably there's something later on that you can use the show that to help you solve. That's where you get follow through marks. Okay, so here we're going to the next part, hence solve the equation. Even if I did not do the work for part A, I can carry it and use it in part B. And that's why they structure these questions the way they do, because they do want you to be able to get points. Yeah. Okay, so we showed that this equation, now hence solve. First thing I'm trying to look at is I've got my equation and I'm trying to figure like this looks similar, but like not quite. But I see that I've got some angle measures here. These are different. I'm going to want these to be the same. So if I factorize 4 in the front here, I've got matching angle measures. That's important. We want matching angle measures on a paper 1 question to be able to solve. Okay? So now that they're matching, I can say let x equal this angle measure. I'm trying to simplify. This is kind of bulky right now. I don't like how much is going on here. I can call this any letter I want. I'm going to call it x. And then I'm going to get this equation. This is not so scary, a little bit nicer, especially because I just worked with that equation. Okay, so slow down, think of some things. I have to have the same angle measure. How do I do that? Okay, let's let this equal another value. Oh, look, I got what I need. Okay, so now we're going to substitute the left-hand side of the equation. We're going to change that cosine 4x to this long expression that we found. And now I'm going to try to solve this, right? I'm solving this equation. This is really just a polynomial equation. I've got a power 4, a power 2, and a constant. So let's move everything to the left-hand side and set it equal to 0 because we know how to solve these polynomials. We're actually trying to make this a quadratic, right? So I'm saying 4, 2, and constant. That's good. This looks like it could be a quadratic. And I'm going to do that by letting a equal cosine x. Right? If I let this be a, then this will be a squared, and then I've got a quadratic. That's something we can work with. Okay? So in doing that, now I've got 8a squared minus 6a plus 1 equals 0. We thought we started with a trig equation. Now we're suddenly in quadratics. That happens. Um, and so this is our x value, this was our a. Remember, we've let a couple things equal. To solve this, we got to go backwards later. But we have this quadratic. It's not too bad. I'm thinking about how to factorize this. So I'm looking for two numbers that multiply to 8 and add to 6 or minus 6, right? I'll choose my signs in a second here. And the 4 and the 2 work. So I'm going to put 4a and 2a in the front. I know my only factors of 1 are 1 and 1. And I need these to be negative because I want to have this negative sign here. And so here's my factors. You can always go to the quadratic formula that's in your formula booklet if you need these. Okay, so we've got our two factors. We'll set both of these equal to 0 separately. If I do that, I've got 4a minus 1 is 0, 4a is 1, and a is a fourth. If I do the other one, 2a minus 1 is 0, 2a is equal to 1, a is equal to a half. So these are a's. This is good. We're in the right direction, but I'm still looking for theta, right? I've got this thing here, and I'm looking for theta, solving the equation. I don't want a, so that's okay. We had a was cosine squared, so we'll go back. We'll replace a with cosine squared. So I got cosine squared x is equal to a fourth. Cosine squared x is equal to a half. I'm going to deal with those separately. Take the square root of both sides. I get positive a half. The square root of 1/4 is plus or minus 1/2. The square root of a half is this root 2 over 2, or 1 divided by root 2 over 2. Yeah, if the factorizing held you guys up, don't worry. At this point, I would say go to your quadratic formula. Trying to learn how to factorize now, it's a little too close to the exams, and it's fine. The quadratic formula will absolutely work. And when I say quadratic formula, it's this negative b plus or minus b squared minus 4ac all over 2a. Okay, you can always use that formula. And in our case, a would be 8, b would be minus 6, and c would be 1. Okay, so if this part over here got you a little bit, whoa, I don't know how to do that. That's okay. Do the formula. Okay. And so back over here, we got these cosine values. Now we need the unit circle again, or the table, or the triangles, or whichever one you decide you like. We'll figure out what is x when cosine x is equal to a half. I'm going to get a bunch of answers, right? 2 of these are the positive answers, and 2 of these are the negative answers. I've got the whole unit circle. And same thing over here. This is, so this would be pi over 3, right? This is pi over 3 in all the quadrants. Over here, this is going to be pi over 4. And I'm going to have the pi over 4 in all the quadrants. Okay, keeping it around here. That's why instead of from 0 to 2 pi, we're keeping it around 0. And again, I'm still looking for theta, not x. So we got to go back another step here. And so we'll just say theta is equal to these values. But I don't need them all. I need the ones that are going to be in this domain. So I'm going to take these ones, right? These ones that are centered around the middle is going to be what I need. These ones are going to be too big. They're not going to fit in my interval. But you could always work with all of them. You lose a little time, but if you're not sure, test them all and then select the ones you need at the end. Okay? All right, so we've got x is theta over 4. These were the values that we decided to work with. Theta is x plus 4. I just moved my pi over 4 to be with the x, and then I can substitute all of these values and get answers. I'll put these up for you guys to look. Let me see, I got a question. Mention the key steps for similar equations. Similar equations. What do you mean with similar equations? So like key steps for solving something like this? I mean, with your trig equations, you definitely want to check that you have the same angle measure. Okay, so if you see what I mean by that is like these are not of the same form. So the first step we did was factorize 4 so that the angle measure was the same. Similar question. I'm sorry, I don't entirely understand. The questions are so, I mean, they're similar, but they're not. So asking about similar questions. I mean, the ones that I'm including here are the one there. These are similar to other types of trig equations. Uh, I'm not sure I understand. Keep trying. Okay, send me some more messages. I'll keep an eye. Um, so yes, back over here, we got all of these from our unit circle. We selected the ones that we thought were going to fall into this domain, and then we set it back equal to x and substitute them in, right? We want theta, not x. So when I add these together, we would need a common denominator. So we would have, what would we have? Minus 4 pi over 12 plus 3 pi over 12 is minus pi over 12. We would get all of these in the denominator of 12. This is kind of nice if I'm just adding negative pi over 4 and pi over 4. Same thing, these are already in common denominators. Right, so this negative pi over 3 times 4 over 4 plus, I'm just going to demonstrate one of these quick, 3 over 3. So we could get a common denominator. We'd multiply by 1. Similar question. So I mean, show that you're going to try to use identities. Okay, so show that question you want to use identities. Solving is going to be quite similar. You try to get it into a single trig ratio. You try to get the theta by itself, and you may need to use identities. I still don't know that I'm answering that as well as I could. I'm sorry. The thing about the trig is it's a big, I say it's like an iceberg. You guys probably feel like you're learning a lot of trig. There's so much that's left untapped. And there's so many ways to phrase the questions that they can be similar, but like there isn't a set. You always do this, you always do that. I'd say the best advice is to keep practicing as many different types as you can. Look at Revision Village. We got a ton of questions that can be helpful. Talk to your teacher, maybe some past paper questions. Just got to try to practice and see what you can pick up. And the other thing, just shifted answers positively, right? So if I'm x plus pi over 4, shifted all my answers. So just a little bit of a note. If I wanted to check for another answer, if this is shifting everything positive, I'm going to check the answer that's a little bit on the left side to see if it still counts. And when I check, this is still inside my domain. Okay. Again, these questions are asking for like 4 or 5 answers. IB doesn't tend to ask for so many. But I think if you practice with these, it can really help you know what you're looking for. Okay. So just things to keep in mind. All right. We are sort of working. Again, calculator. Let me just clear that up a little bit. Even if it's a paper 1, if you're practicing, right, on the exam you can't, but while you're practicing, graph this thing. See, what does it look like? Do my answers make sense? Did I find all my answers? Right, if we look at this, I've graphed the red curve, that's the negative, that was the right-hand side of the equation, right? That was this part here. And then I've graphed the left side, that's the cosine 4x, and I see 1, 2, 3, 4, 5. So if on my paper I've only got 4, okay, oh, I got to go find another one. How do I find another one? Think about the ones that we didn't take and consider, do we need to actually put that back in there? We do. We shifted answers positively, so we want to take the one that was negative that might have jumped into our range with the shift. Okay, couple more. And these ones are a little bit different. These are the word problems. So these might be part of like a section B question. They might be section A too, but they do like to try to get some sort of situational question, some word problem. And so let's look at this one. If we see here, this is a calculator. So we'll have the calculator. Just let me, if I bring up my calculator, you guys can see this, right? Let me know. I'm going to put it away for now, but just somebody let me know that you saw that. I think I shared the screen the right way. All right. A water trough 10 meters long with a cross section in the shape of a semicircle with a radius of 0.5 meters. So this isn't super clear, but essentially we would have like this 10 meters long is like going back there, right? We're looking at the cross section right now. Okay. So determine an equation in terms of theta for the volume of water in the trough. Yeah? What is happening there? Okay. We have the volume of water in the trough. Like this is our water, right? So essentially we need to figure out an equation to show that shaded area. First thing I'm seeing is that I have this sector area based off of theta, right? And so here is our sector area, r squared theta. It's in the formula booklet if you don't remember. And I need to take away the white part that I don't want. I don't want this. There's no water there. I need to take that away. So I'm going to subtract the area of my triangle. Okay, again, area of a triangle is in the formula booklet. Okay, so you can grab that. And then if we want to find an equation, we can substitute r. This is the same r for both the triangle and the sector. So, excuse me, we substitute that in. We can simplify a little bit. And we get this. So just in case, got 0.5 times 0.5 squared, 1.25, same for both parts of my equation. And so now I have this expression. Now, this is area. Notice I've talked about area here. This is only on my cross section, but I'm looking for volume. Volume needs to have another dimension. Okay. And so I'm going to remember this is the 10 meters long. And so if I want to take my area, multiply it by my length, I'm going to multiply this whole thing times 10. And that will take me to my volume, which is 1.25 theta minus 1.25 sine theta. Okay. Again, like I said earlier, read back the question. Maybe you jump in, oh, area, this is a nice area equation, and you work forward. You look back, wait a minute, I'm supposed to do volume. Okay, so make sure you're reading, highlight questions, underline, whatever you need to do to remind yourself to answer the right thing. Okay, so there is our volume equation. Cool, part A. All right. So a sensor is placed at point A, so that's here. One thing on your test paper, mark up your pictures. If they've given you a graph, go ahead and mark things on it. You're not going to lose points for that. It might help you trigger some memories. Okay, so like I said, I'm reading this. Sensor is placed at point A. I'm going to remind myself. Okay, so at A, given that the sensor is exposed to the air when AB is 0.3, so I'm going to draw right here. This is 0.3. Okay, it helps me to sort of process the information. Now I need to find theta. Okay. AB 0.3, I think that's going to come up. Yep, I'll erase that. And I know that both sides of my triangle, my radii of my circle are the sides of my triangle there. I have measures for all three sides of this triangle. When I have measures for all sides of a triangle, I can use cosine. So we'll go to the formula booklet, we'll get the cosine rule. Okay, and there's two forms of the cosine rule. Here's one of them. All right, cosine theta is going to be depends in this case. Let me see. I'm going to do this. So cosine theta is equal to a squared plus b squared minus o squared divided by 2ab. Okay. Just a little minute. Like if I'm labeling my triangle, that's small a because it's across from big A. This is small o because it's across from big O. And this would be small b because it's across from big B. Okay, so that's why I just put that in there. Sometimes that's something that gets a little confusing. We label it with the opposite, same letter, big for angles, small for sides. And so we can substitute this into our calculator. And do this all right away. Actually, what I would do, I would say if I'm looking for theta, I'm going to do inverse cosine of this. I'm going to do it all in one shot. Okay, so I'm going to do trig inverse cosine of, if I've got my fraction, 0.5 squared plus 0.5 squared minus 0.3 squared And you could put brackets in there as well. It probably is good practice to put the brackets in. And I'm getting 34.9. That is in degrees. Maybe I go back. Uh-oh, I wanted radians. That's okay. Click it. Go on up. Select it again and get the degree measure. Okay, no need to retype it all. So I get this. I could have gone the middle step and then taken the inverse cosine, but we could do it all in one step as well. It doesn't really say anywhere. Theta tends to indicate radian measure, but it's not going to be a big deal. They haven't told you to use degrees or to use radians, so you can give both answers. Theta tends to indicate radians, x tends to indicate degrees, but nothing to worry about. Yeah, both answers would be accepted for sure. And we round to three significant figures, okay? I always, always, always tell my students to write a lot of decimals and then round it to three. Because if you have more decimals than you need, the examiner will give credit, okay? You should round just because it's good practice. It doesn't take a long time. But when in doubt, write extra decimals on the math exam. I know it might be different in sciences. On the math exam, extra decimals is good. And carry all those decimals with you to future parts of the question. Okay, I'll show you on the calculator, I think, how we can do that here. Determine the amount of volume of water in the trowel when the sensor emits the signal. Okay, so basically, the sensor emits the signal once the water is up to this point. And so determine the volume of water. We had that volume equation. We found that this signal emits when theta is the 0.69, 0.609, sorry. And we need to figure then what is the volume? Well, we substitute the answer from B into the answer from A, and we will get our answer. All right, again, in the calculator, I see it's supposed to be 3. The IB wants 3 significant figures, but if you go 3 decimals, that will cover you. Remember, more is better. Sorry. It might say, sometimes the question will say, give your answer to 2 decimal places, and then you have to do that. It might say, round it to the nearest whole number, and you got to do that. But for the most part, everything is 3 significant figures. But if you have extra decimals, it's okay. Yes, if they don't mention it, you want to round to 3 significant figures. I think it's mentioned in the directions. Like if you read the front page, which not a lot of people read, I think it says in the answer on the page 1 where it tells you what exam you're taking, that's where it says it. It does say it, but it's hiding a little bit. All right, just over here. So we want to calculate this 0.125. Make sure you go up and get your, whoops, I forgot to put the multiplication sign. You're going to go up and select it, okay? Times. And actually, this is where it's going to matter which degree or radian measure you're using. Sine of my previous answer, right? So I'm taking all the decimal places to get to this final answer here. And see, I've written them all, or I've written a lot, and then I rounded it to 3 significant figures. With these questions, this is where someone earlier had asked, yeah, we need to keep it in radians. And someone asked earlier, why? When we're working with our circle theorem stuff, so like our sectors, if it's just the angle measure, it's fine. But when we're multiplying here, 1.25 times theta, our answer will be different if we're using 34 degrees or if we're using radians. And so this is why I would encourage you to keep it mostly in radians, unless you're specifically working on one question in degrees and then switch back. Yeah. Yeah. It is confusing. I agree. I think the safe way is mostly in radians, switch it degrees for 2 degrees for specific questions and switch it right back. Okay, cool. All right, so we're not done yet. I do have one more question. If you guys got to go, I get it. I'm going to, there's a QR code there. Let me just, actually, I'm going to copy all of this. So the pre-reading document is there. The slides are there and this feedback form is there. And I do, we all look at the feedback. So please feel free to let me know if I did some things good, if I could improve some things, I would appreciate it. I will be giving more sessions in the future, so I would like to know how I'm doing. I feel like I'm going a little bit slow, but maybe not. Maybe too fast for some of you guys. It is tough when we got a bunch of people in a room. But one more question left. If you've still got some time, hopefully we can do it. Looks like we're aiming for that 2 hour mark. And here we are. Okay, so in the chat was that feedback stuff. Okay, another word question. Wheel has a radius of 14 meters. When the riders are at the highest point, they are 32 meters off the ground. Find the minimum height of the ride. Again, mark this up. Okay, like go ahead and add things into this picture. This height is 32. My radius is 14. Put it right on your diagram. My radius is going to be both up and down, right? And so the minimum height of the ride, that means when I'm here, right? I'm going to be on the ride, but I'm at the minimum height. So I can figure out that my minimum is going to be 32, which is this maximum, minus 2 of my radii, my diameter of my circle. And so my minimum must be 4. And again, you can write this as a nice little sort of equation there like I have, or you could just, if you just write down 4, you'll get credit in this case because it's probably only 1 or 2 marks anyways, and it would be an implied mark. Okay, so you don't have to stress out about how do I write this? Oh my gosh, if you find 4 because you just did it in your mind, that's okay. Okay, let h of a of t is equal to 14 sine b t minus c plus d, where b, c, and d are within real positive numbers. Hence, find the value of d. Okay, so it's guiding us through. We're not worried about b or c yet. We're worried about d. So if we're thinking about the height, right, we're thinking about just it's going around, it's going up, and then it's coming down. And then it's going back up again, it's going down again. This is a sine curve or a cosine curve. And we can think about, well, I started at the bottom and I'm going up. And so we can try to, wherever I'm starting, I'm going up and then I'm coming down. And so I've got this curve here. And remember d, this d value at the end of our equation is the midline. Okay, so again, draw yourself a little sketch, draw yourself the midline, and think about how do I get to the midline? Well, I can either subtract 14 from the maximum, or I could consider it in the middle here, or we just found that this was 4, so I can consider it all the way from the 0 axis as well. So however you want to think about that, we can figure out that the answer is 18. Okay, this was the formula that I showed you guys earlier, the maximum plus the minimum divided by 2. Okay, so that works. Or you can just, you've got yourself a little diagram, you figured out that the midline will be basically this horizontal line on my Ferris wheel, and so this must be 18. Okay. Given that the riders complete one rotation every 80 seconds, find the value of B. So we're thinking about if we have this starting at A, it's going to take 80 seconds to go all the way around. And period, remember, period is one full rotation. So 80 seconds is the period. Yeah, 1 sec. Okay, so 80 seconds is the time it takes to go around. That is one period, okay? So if I'm looking for the value of b, I have that equation we mentioned earlier. Period is 2 pi over b. I'm using this one because of sine, okay? Again, you're always checking back. Am I using the right equation? If this was tangent, it'd be different. But it's sine, so I can use this. Period, we said, was 80 seconds, so I substitute that in. I cross multiply. That will put the 80 on the denominator, and I can reduce this to pi over 40. Okay, so I'm starting to build this equation, right? B is pi over 40. We said D has to do with, someone was asking again about D, so I'm just going to back up. I need to know D, this value D in my equation, is the midline. It's how much this thing shifted from where it used to be. This green line over here used to be at 0. On a standard curve, it would be at 0. But I can see here that mine is not at 0. Mine has moved up. I need to know how far it moved up. And it's going to move up. The minimum distance of my curve, which we just found was 4, that's this part here, and also the extra 14 radius. So I can just add 4 plus 14 to get there, or I can figure out what is my maximum, which was 32. They told us that. I can figure out my minimum, which I found that out too. That was this part here. And I can use my formula, max plus min divided by 2. So 32 plus 4 is 36, divided by 2 is 18. Okay. Couple different ways. Again, everybody's different. Everybody's mind works a little differently. Figure out what makes sense for you. Okay. All right, so we found D, we found B. I suspect we're going to have to find C next. I mean, I don't see the question on the screen, but I think that's where we're headed, right? Okay, riders begin at point A. Do I have my graph coming back? I don't. Okay, but here's my information. So we found D, we found B. If whatever values you get, bring them forward into your equation, okay? Hopefully they're correct, but if not, you get follow-through marks. Okay, so we found these values, we substitute them in place of B and D. Begin the ride at point A, okay? At a height of 7.5 meters. So this is a hidden way of saying we're going to start at time 0 and we're going to have a height of 7.5. So hiding in my question here, begin the ride, that's time 0, height of 7.5, and I can write that down, and now I can substitute those values in to solve for C. Okay, so H goes on the left, 7.5 is equal to 14 sine. This is B, pi over 40, times 0, 0 minus C, plus 18. Yeah. And now I've got that answer popping right up on the screen. There's a couple ways that we can do this. You could use your equation solver. I think a lot of people like their equation solver, and there's nothing wrong with the equation solver, but, little caveat here, in the trig stuff, we've got lots of answers, right? I mean, we mentioned a couple different times throughout the session today, like there could be a lot of answers for C. And so we kind of want to, I really like to see the visual. So I would maybe encourage you to consider drawing a graph. Okay, so if we do that, we've got 7.5. Enter. I can't see it, it's a little too high, that's okay. I'm going to come back up here, I'm going to enter the other. So that was the left-hand side. This is going to be the right-hand side. Sine of function pi over 40. I've got minus C. Actually, we're going to minus x. Remember, this is a function of x. So I got to, of course, I should have brackets there. Bracket plus 18. Enter. Okay. I can't see that. That's okay. Window settings. I know that my minimum was 4. I'm going to go from 0. Actually, let's go from 0. Time is, we said 80 seconds, right? So 0 to 80. And then our minimum, I'm going to go from the ground, that's 0. And I know that this thing goes up to 32 because they told us that. So let's see if this, oh, nice. Okay. So using your info from the thing, we can figure out, and you'll see right here, I've got 2 answers. Okay. But that's okay. We can think about which one do we want. We'll do menu, analyze graph, intersection, and I bound left, bound right. And there's one answer, menu. I can grab the other one, bound left, bound right. And so we've got 2 potential C values. In the exam, I don't think we have anything here. Find the value of C. I would probably give this first one, as you've seen on the screen. I'm trying to decide, would you get credit for the second one as well? Probably they've given you information about the first time it's equal to this value. Okay, so honestly, what I'm thinking, and if we're thinking about this in context, probably we're here, we're going forward, and then we hit 7.5 again, right? We started at 7.5, we got back to 7.5, and then we do the loop around. So that was the curve that we're looking at. Right. I think both answers would be accepted unless they said give your answer less than 12, right? If they say C is less than 20, C is greater than 30, like they're going to give you some extra information if there's multiple answers. They don't want to make you guess. Okay, so if you're getting answers, check the question, see if there's some extra guiding info that will help you. Okay? All right, so we got this answer. And this is just for our equation. Remember, this is a shift, so you should be fine even if you're using your other answer. All right, when a rider has an altitude of 30 meters, they can see the library. Given that Ava rides the Ferris wheel for 12 minutes, find the probability that at any given moment she can see the library. They do like to change the Part B questions into multiple types. Okay, so 12 minutes. I see I'm short on time, so I'm going to pick this up a little bit. Period is 80 seconds. So if I'm on it for 12 minutes, I need to multiply that by 60. And so I'll have 720. And then I want to figure out how many times am I going around, right? So if I divide that by 80, it's 9 rotations. So in 12 minutes, she's going around this wheel 9 times. And I'm doing that because I want to figure out how I want to see what this looks like. Okay, she's got an altitude of 30. I'm gonna go back to my calculator. Let's change this. If I go up to my tab, I'm gonna go up and I'm gonna change this to 30, right? That was my new value that we're considering. And I'm also going to change my window because now I need to see 9 rotations. Okay, so window settings, we just said that was 720. And so now it's a little crowded here, but we can see these tiny little bits above the blue line. That's where she can see the library. And we're looking for the probability that she's in that tiny little bit above the blue line. Okay. So I've set this equation equal. That's what I just did in the calculator. And I want to figure out the amount of time she's above that blue line. Okay, so what I'm gonna do, I'm gonna bring that back. I need to know how long is it from here to here. I'll bring that bigger. A little bit hard to see when it's small. How's this? Okay. I need to know the length of time to get from here to here because then I can multiply that by 9. These are all symmetric. So if I can figure out this piece here, then I can figure them all. So I'm going to go Menu, Analyze, Intersection. I want to know what is this point up here. Okay. And then I want to know what is intersection, this one here. And so then I can figure out, this is how many seconds, right? We set this in seconds. So I can figure out how many seconds she's above this 30 line. So I would subtract those two. Just a little, if I want to click on this, I can store this. If it lets me. It's not letting me store. Why is it letting me store? You're going to want to, Control copy. If I want to come back over here, Control paste, Control V and Control C. Oh, goodness gracious, what happened there? Clear. All right, we want to subtract these values. Okay, so 66.8899, we're going to subtract. We'll figure out how many seconds that is, and then we'll divide by the whole number of seconds. Okay, so 66.88 minus 53.11, figure out what that is. That's 1 time. We multiply that by 9 because there's 9 rotations, and then we divide by 720 because that's the whole time she's up there. Okay, I've got this in slightly different excuse me, measures here. So actually, I didn't switch I explained that I didn't switch this 10.8, did I? I was still solving the old equation. So that's why these values are slightly different. Okay, so it's good to draw a sketch or something, maybe to indicate. You would have gotten method marks here. Okay, so I would need to go in, I see that I'm at time. I would need to go in and change this equation so that it matched properly. And then I would do the same process. Okay, I'd figure out where it's above 30, find time one, find times two, subtract. So that's one section of time above the line. I'm going to multiply it by 9 because there's 9 sections where she's up at the top of this wheel in the given time. And then for probability, I need to divide by the total. So I'll multiply this here. And when I divide by 720, I get this. And we would round to 3 significant figures. Okay. It is time. I'm not going anywhere. So if you guys need to go, I completely understand. I'm going to share those links again. Happy to hang out for another 5 minutes or so. If you have any questions, if you want me to show this properly, I can go back in and fix the equation and do it properly. But if not, thank you guys for coming. I do hope that it's been helpful. We looked at some basics. We talked about the functions. We did some equations and identities. And most importantly, good luck, study, practice, ask all the questions before your exam, and just do your best. That's all you can do. And good luck. Good luck. Thank you guys for coming. Again, if you want to stay for a minute or two, by all means, I'll hang out. Altitude means in terms of graph. So altitude is like your height. It's not your amplitude. Someone's asking about altitude. So altitude is the height above the ground. So it does indicate vertical stuff, so like your A and your D values, but it's not the same as amplitude. Amplitude is literally the height of the curve itself. Okay, so the altitude, if I go back to this question here, right, your altitude would be like, it's either 4 or maybe 18 or 32. That's how high you are. But the amplitude is only the part between the center of our sine curve and our maximum. Okay, so a little bit different. I'm glad it's been helpful. Good luck, guys. Thank you so much. Tutors one-on-one. We do have RV tutoring. I am not sure. Look on the site. RV does have tutoring. The other thing you could do is you could email right into support. So if you go to our website and you go to support, we have a very nice woman who does a lot of the communications, Katarina. She's super helpful. So if you write into the support and say, I'm really interested in the one-on-one tutoring, how do I do that? They will absolutely send you the information that you need. Okay. Oh, good. I'm glad that I was able to help you. I'm trying to think if we will be doing more sessions in the future. If you're doing the October exams, I mean, it's super close. But we'll be doing more sessions for May as well. So yes, any more questions, let me know. I'll just go back to this. Oops. Oh no. Keep it. I'll just, I think you guys can still see this. So we'll just come back over here. Any more questions? I'll hang up just another minute. And thank you guys so much for coming. I know you're busy. All right, I'm not seeing any more questions. Thank you guys so much. Go through the slides again. We'll get the video up as soon as we can. And just practice, practice, practice. Bye, guys. Do